Rashi.
Our POTD question was given a director link graph with V vertices numbered from 0 to V to 1 and E edges represented as 2D arrays, edges two brackets where each entry edges sub I equals UV denotes a directed edge from vertex U to vertex V. Find the maximum number of additional edges that can be added to the graph without forming any cycles. Note, the resulting graph must remain at DAG, meaning that adding any further edges would not create a cycle. Looking at this problem, we need to find the maximum number of additional edges that can be added to a DAG without creating cycles. The key insight for this problem lies in the fact that the maximum number of edges in a DAG with V vertices is V times open parenthesis V minus 1 close parenthesis divided by 2, which corresponds to a DAG that follows a total order or topological order of vertices with edges from every vertex to all vertices that come after it in the order. Given a current number of edges E, the maximum number of additional edges that can be added without forming any cycle is simply max additional edges V times open parenthesis V minus 1 divided by 2 minus E. This is because adding any more edges beyond this would necessarily create cycles. The time complexity for this approach is O of 1 and space complexity is O of 1 as required. Here is my solution. This is a current number of edges. This is maximum number of edges in a DAG with V vertices. This is maximum additional edges that can be added without forming a cycle. Explanation: the maximum number of edges in a DAG with V vertices is V times open parenthesis V minus 1 close parenthesis divided by 2. This represents all possible directed edges from any vertices U to any vertex V, where U comes before V in some topological ordering. We already have E is equal to edges that length edges. Therefore, the maximum number of additional edges we can add is V times open parenthesis V minus 1 close parenthesis divided by 2 minus E. Why this works? In a DAG, we can always find a topological ordering of vertices. In this ordering, we can say add any edge from a vertex earlier in the ordering to the vertex later in the ordering. The total number of such possible edges is exactly V times open parenthesis V minus 1 close parenthesis divided by 2. Any additional edges beyond this would either be duplicate or would create a cycle. Here the time complexity is O of 1 and space complexity is O of 1 as required. Let me submit the code. My current streak is 337 days. Let me push my code to the GitHub. Message of the commit is add solution for finding maximum additional edges in a directed acyclic graph DAG with examples and constraints. Commit and push. Message and the file is committed on GitHub. If you have any doubts, put it in the comment. Thank you. To get more awesome videos, like and subscribe this video.